Alright, this is a little video on setting up an Arduino board and writing a simple program to make an LED blink. So in the corner there, you can see I've got an Arduino Uno board connected by a couple of jumper wires to a breadboard. The breadboard has a resistor and an LED. Now that resistor is important. LEDs by their nature draw more current than they can handle and burn themselves out, so you have to put a resistor in series with them. So if you don't have one, you'd better get a resistor to save your LED or it'll burn out in short order. Okay, so here is a schematic circuit diagram of what's going on, just so you can get a feel for it if you're not familiar with how breadboards connect the pieces together. This is what's really happening. So from the Arduino, we've got coming out of the ground a wire that goes straight into this resistor. A wire then comes out of the resistor into the LED, and the other side of the LED leads back to this, which says D13, and don't mind the other part. That stands for the digital input-output pin number 13. There are 13 total digital pins available, and 13. Well, you'll see why we picked 13 in a minute. All right, now the jumpers in the video stream there are available on Amazon or wherever. They're really nice to have. You can just use regular wire, but you have to strip the ends off of the wire and everything, so it's really nice to get these, and they're just a couple of bucks. I don't know, make sure you get the male ones so you have the pins on both ends. And the schematic software I was just showing you is called Fritzing. It's free. It's pretty simple to use, and there's some other nice features as well. So you can get it at fritzing.org. Another feature, here's back to the Fritzing software, is you can view a nice looking image of the breadboard. I just set this up so we could get a better view of it. It's basically the same thing. I even made the wires the same color right as the actual video feed. Just looks kind of nice. You know, it's a good way to plan out a project, or if you have like a report to turn in, it might be a nice way to, you know, give a really nice vector image visualization of what you've done. Okay, so you can even like plan out how, if you were going to really do a project and print a circuit board out, you could plan all that out and everything. Another thing to mention is you can see that there's no shield on top of my Arduino. I'm not going to be needing anything like an SD card reader writer. So if you have a shield, you can just pull it right off if you want to do this little project. Alright, so let's go ahead and open the Arduino software. This is what it looks like when you first open it up. It's got this void setup that's empty. Now this is just a comment. A comment is ignored by the computer, by the compiler. You make a comment by putting these 2 forward slashes, and that these braces comprise the entirety of setup. So that brace opens the setup, that brace closes it. Then for loop, same idea. That opens it and that closes it. Right, so let's write a little program to make it blink. Oh, you know what? First, let's make sure we're connected. So my Arduino board is plugged into my computer right now with the USB cable, and I should be able to find it in here. First, I should go to Board, in Tools, then Board, and make sure I have the Arduino Uno selected, or whichever board you have. As you can see, I have the Uno. In the past, I had this however you say that, but they've all worked pretty much the same, so Uno. And then you also want to pick the right port, because you have multiple serial ports, USB ports that is. The S stands for serial. And so I've got a couple of options. Now it looks like it knows that I should pick 5. It's saying that there's an Arduino Uno connected to 5 in. That's not always the case. I remember it doesn't always say that. So if it's not working for you as we continue this video, if something doesn't work, go and try a different COM port. But I know that COM 5 is the correct one for my setup. Alright, so now let's start writing the program. So what I'm going to do is I'm going to write a program that just turns that LED on. How about that? So by convention, when you're inside of a function, you tab in by one tab. So I'm gonna, I'm gonna go ahead and get rid of that stuff actually. Okay, so tab in one tab. So what we're gonna do is we're going to, in the setup, tell that pin that it's an output pin, pin 13. So the way that you do that is you type pin mode. That calls the built-in function pin mode. It tells the chip that pin 13 is going to be an output pin. And you end every line with a semicolon unless you opened a new function or something with a brace. Like this up here, as you can see, does not end with a semicolon because it's a brace instead. Watch that not be a correct rule, but I'm pretty sure that'll cover you. Okay, so that makes pin 13 an output pin. Now this won't do anything visual on its own, but we need to do this because all 13 of these pins are capable of input or output. So I'm just going to tell it for the entirety of this program, we're going to be using pin 13 as an output pin. Okay, now for anything interesting to happen, we need to do something down here in our loop. Well, I think we could also do it in the setup, but let's do it in the loop here. So so we made it an output pin, but we didn't actually turn it on. So in order to send some voltage out of pin 13 to the LED, we are going to use the function called digital write. Digital write. One of the things I love about the Arduino platform is they use what's called camel case. See how there's no spaces? Instead, they put an uppercase letter where the new word starts. Another option that many programming languages and things use is an underscore instead. I find that very ugly. Computer programmers have a lot of weird opinions about things that don't matter. Alright, so we're going to digital write to pin 13, which will work because we said it's an output. And we're going to write high, as in I'm going to send voltage to that pin. It's high is 5 volts and low is 0 volts. Now this is a digital pin, so those are our only two options. Should work. So you know what, I should probably put in some comments in here to remind us for later, right? So earlier I made this, so sets pin 13 as output. I don't know, is that descriptive? Sure. Pretty much doesn't add anything that this doesn't already say, but whatever. Now here we're gonna sets pin 13 voltage to high, and that's 5 volts. Okay, so that should turn the LED on. Won't be too exciting, but let's try it out. So this upload, you can also hit verify. That'll run through and make sure you don't have any syntax errors. Let's try that. So verify. Oh, it's going to make me save it first. Fine. Sure. So it says done compiling, and we've got some white words here. Everything looks good. If I had made some sort of syntax error, like say typed a bunch of gibberish, and hit verify, we've got a compiler error. See that? And it's got some details. It said it expected a semicolon, whatever, it's just gibberish. So let's not ruin it. Alright, so you don't actually have to hit verify. You can just hit upload. It'll verify it first. It'll try to verify it automatically. So upload. And there we go. The LED lit up. Very nice. So, kind of boring. Let's see if we can make it blink on and off. This is a loop after all. So what I'm going to do is I'm going to turn it on like we have done, and then I'm going to delay for, say, 1 second. Now, the delay function actually takes an argument of, let's see, milliseconds, and there are 1,000 milliseconds in a second. So we're going to delay. Okay, it's not necessary to line up your comments, but that's another weird programmer thing. So delay 1 second, which is 1,000 milliseconds. Alright, now after delaying 1,000 milliseconds, let's turn it off. Let's turn the LED down. So, watch me be lazy. I'm going to copy this line that turned it high, And I'm going to paste it right here. Love copy and paste. And instead of digital write 13 high, I bet you know what I'm going to do. Digital write 13 low. And that will set pin 13 voltage to low, which is 0 volts. Okay. All right, now you might think that we're done, but let's look at this. Imagine that you're the computer. This is the best way to debug your programs. So if you're the computer, you start, you're reading this file, you read setup, you read this, okay, I'll set the thing to output, fine. Now you're done, you're never going to go back to setup. Now you're in loop. Okay, digital write 13 high, alright, I'm going to set this 13 to high. And I'm going to wait 1 second. 1 Mississippi. Okay, now I'm going to digital write 13 to low, and now I'm going to loop up here and digital write 13 to high. That'll happen instantly. So what that means is we need to wait while it's low, or we won't see it. So now after it writes it to low, it'll go 1 Mississippi and then high. 1 Mississippi, low. 1 Mississippi, high, and so on forever and ever. Okay, so I'm going to upload this and see if we get a blinking LED. Oh, yes, we do. I forgot where I was looking. There it is. Very nice. Now, I don't know if you can quite see, but there's actually an LED right on the board, right near the GND and the L. The Arduino boards actually have a built-in LED on pin 13, and that's just for situations like this where you're just practicing. So it turns out you don't even need to build this little circuit to practice this program. Maybe I should have opened with that, but that is why I'm using pin 13. Okay, neat. It's blinking. So, I don't know, let's just play around with this a little bit more. For example, in our program over here, pin 13, using the number 13, well, that's okay, but it's kind of meaningless. In a more complex program, we'll have an LED in one pin, we'll have a humidity sensor in another pin, and we'll be writing to an SD card using other pins, and so it's good to name these pins something. So here's how you do that. I'm going to make a global variable up here, an integer named, I'm going to call it LED pin, and I'm going to set it equal to 13. Okay? So LED pin is 13. And there's a better way to do this too, but this is the most general. It's creating an integer variable. So its name is LED pin, but all it is a 13. So wherever LED pin is, the computer's just going to stick a 13 in there instead. So, you know, we had the 13 here, so we're setting LED pin, which is 13 to output. We're writing high to it, we're writing low to it, and so on. So let's upload this one now and verify that it's still working. There it is. Another nice thing about this is, what if for some reason I wanted to change my circuit? Let's say I wanted to put the LED pin down here in 8. The way the program was before, I'd have to go and change that 13 to an 8 in 3 places. But the beauty of this is I just have to change it at the top now. So I'm going to change our LED pin to pin 8 because I just changed that in the circuit, and upload again. And we should still see a blinking LED. Alright, so now the LED is in pin 8, but it's still blinking. And note that that little built-in LED is no longer blinking because it is it's attached to pin 13. So we're not using pin 13 anymore, we're using pin 8. But who cares? Whatever you want. Alright, so that's kind of nice. You can play around with this a lot. You can set the blink rate way higher. Let's try just stopping for 1/10 of a second each time. Okay, that's a little more interesting, I suppose. Alright, well, I suppose that is all for this video. I'll make another now.